Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data migrations are brutal. They drag on for months, sometimes years, burning through resources and crushing team morale. Datafold's AI-powered migration agent changes all that. Their unique combination of AI code translation and automated data validation has helped companies complete migrations up to 10 times faster than manual approaches. And they're so confident in their solution, they'll actually guarantee your timeline in writing. Ready to turn your year-long migration into weeks? Visit dataengineeringpodcast.com/datafolds today for the details. Your host is Tobias Macy, and today I'm interviewing Roman Gershman about building a high-speed in-memory database and the impact of the performance gains on data applications. So, Roman, can you start by introducing yourself?
Nice meeting you, Tobias. And I am Roman. I am the CTO of Dragonfly DB and also the original author of a Dragonfly project hosted on GitHub.
And do you remember how you first got started working in data?
Yeah. So I joined Google actually in 2007 in Israel, in Haifa. And my first data-oriented project was building Google Suggest, which is a service that everyone uses when they type their search queries in the search box and they get all those suggestions. And believe it or not, it hasn't been launched before that. Nowadays, we are all used to it. But back then, it was a 20% project of someone in Google, and we took it on ourselves to productionize it. And we launched it on YouTube, and the goal was to launch it on google.com. And there, actually, I had my fair share of challenges of how you scale technology to Google scale, basically, when you need to support high throughput scenarios with very low latency. And of course, it was in memory domain with lots of pre-processing pipelines, etc., etc. And there again, my initial experience with scaling infrastructure.
And in terms of the Dragonfly project, can you give a bit of an overview about what it is and how it started and why you decided that it was worth putting the time and energy into it?
Yeah, sure. So after Google, I moved to working in a startup called Ubimo. Actually, my manager and the CTO of that startup is Oded, who is now my co-founder in Dragonfly DB. And back then, when we left Google, we kind of didn't know anything about infrastructure outside of this of Google, and we started learning about all the building blocks and pieces that exist in open source community. And quickly, we discovered Redis and started using it, and it was incredibly useful in our infrastructure stack. But unfortunately, it was very painful to manage and scale. So we naively thought that we'll be able to take snapshots, and we couldn't do it just because in that like our use case was a high throughput, high write throughput, and it just went out of memory. And we tried to scale vertically because everyone in the internet said that it's the fastest data store that exists, very scalable. And then, to my surprise, I discovered that it is not possible to scale it vertically. But we kept using it, but I kind of had this thought that maybe it is possible to make it better, but I kept this thought to myself. And then at some point, this startup was sold to a company, and I moved on to another job. Uh, and I kind of saw that there is an opportunity in the AWS Elasticache team in Israel, and I just wrote an email to the manager there, and I wrote to him that, hey, I'm super excited about Redis, and I think I have some ideas of how to improve it. Could be would be like really happy to join the team, and it worked. Like I joined the Elasticache team and became an engineer there. And actually, there I had the chance and a privilege to learn about lots of use cases of how people use Redis in various ways. And really, Redis is super useful. It's a Swiss army of various data structures. and also how people try to use it. And I saw that the challenges we experienced in our startup were very much similar to how others try to scale Redis and fail, and the same pain points. And I just felt even more strongly that it is possible to improve the technology behind this incredible product. And I tried to advocating this in the company, but I didn't succeed. And at some point, we just decided to separate our ways. I mean, I am still very friendly relationship with Medlin, who is the lead developer now with Valky, and I enjoyed very much working with the team. But I decided, okay, why not try myself to do something better?
And you mentioned Valkey, which is currently the more open alternative to Redis since they changed their licensing. And the other major player that I'm aware of in the key value database space is Aerospike, which also focuses on high throughput, high speed. And I'm wondering what you see as the core problem that is solved or the capabilities that are unlocked by having a quote unquote faster Redis.
Yeah, sure. So, first of all, disclosure, I've never run Aerospike. Of course, I heard about it. I think Aerospike, at least how I perceive it, is more in a persistent domain area. So there are lots of key value stores, and I think it mostly useful for enterprise, very huge scale workloads that have maybe a lower throughput to workload size ratio. So maybe it can be like dozens of terabytes of data, but a relatively low throughput use case. With Redis or Valky or Dragonfly, usually people use it for its very low latency characteristics, sub-millisecond latencies, even for P99, and the throughput there can be relatively high. In addition, as I said before, Redis all in memory and data stores, they have lots of different data structures which being used by huge amount of framework. So Redis is not just Redis; it's the entire ecosystem with all these libraries: Laravel, Scikit, BoolMQ, Celery. So all those libraries is the kind of the front end of Redis for many developers, and they consume Redis. They are those frameworks. So I think this is why this ecosystem is extremely useful because of its APIs and the libraries that were built upon them, and also again high throughput scenarios, job queues, caching scenarios. All this became ubiquitous with Redis. With Spike, I believe it's more narrow use case of key value store and also kind of flavor of persistence around it.
You mentioned some of the common application use cases that I'm familiar with in the Redis ecosystem, that being Celery, application caching, queuing. And I also know in recent memory, one of the capabilities that was added was Redis streams to compete with the Kafka ecosystem. And I'm wondering broadly, what are some of the ways that you see Redis used beyond some of those common, well known patterns, particularly in the context of data pipelines, data engineering workflows?
Yeah, so of course, I can only speak from my experience, and I believe the usefulness of Redis APIs decreases with the API generation number. So the most common ones are the first one, like basic sets and gets, lists, etc. And then the recent APIs, yeah, sure, people are using it like streams, for example, but it's just a minor market share of Redis users. I think to your question is that I wouldn't consider Redis only as a cache or a job queuing engine, even though it started like this. But I see lots of use cases for using Redis or Dragonfly or Valky as a non-cache volatile data store. It's not a database. It doesn't have transactions that can be rolled back, but it's a data store that store like it's a single source of truth, could be for serving data, but usually it's for non-business critical use cases. So, for example, we wouldn't want our bank storing its transactions in something like Redis, but it's totally fine to use it for feature as a feature store, for example. And there are lots of use cases for it being a feature store. So in case of your infrastructure crashes, you can still maybe refill the data store with your cold data. Maybe it's painful and you lose availability, but it's not the end of the world. So this I consider these use cases as non-cache use cases because usually this data store is configured without eviction policy on. So the classical cache use case is with eviction policy enabled, but once it's disabled, I consider it as like a data store use case. And there are lots of use cases like this. For example, with gaming companies, they can store scoreboards per team or player or whatever. Lots of use cases for data engineering applications. Geo APIs, etc., etc.
Another interesting aspect of the work that you've undertaken with Dragonfly is the tribal wisdom that has grown up over the years, that it takes 10 years for a new database engine to really settle in and grow to maturity and sand off all the rough edges. Obviously, the past 5 to 10 years has seen a massive growth in the number and variety of databases that are being introduced, and many of them are already in production contexts. I know a portion of that acceleration is due to the investment in various components that are used to compose a database of those different pieces, particularly in sort of the disaggregated big data stack, but also in terms of like the C star framework that I know that the folks behind ScyllaDB helped to introduce for taking advantage of modern hardware capabilities, parallelism. I'm wondering if you can talk to some of the ways that you approached the implementation of Dragonfly DB and the evaluation and selection of some of those underlying pieces to help accelerate your work so that you didn't have to build all the way from the storage engine, paging system, et cetera, all the way up through to the user interface to be able to get to where you are.
Yeah. So the answer is kind of embarrassing. I had to invent or re-implement lots of things from scratch. But let's start from maybe from the end. One huge assumption that I did when I designed Dragonfly is that we are not going to change the protocol and the compatibility. It was really important for me to make it drop in replacement for Redis. So basically, I didn't want to come up with, I don't know, HTTP protocol or change the semantics of the commands. And it was quite a challenge, I must say, because Redis wasn't designed for multi-threaded engine. So I had to adjust Dragonfly technology towards 250 commands that were not designed for multi-threaded scenarios, or for for reusing multiple CPUs. It was quite a challenge, but at least in terms of the product design, if you're talking about reusing components, I thought that the most important decision that people that use Laravel, Celery, and Boolean Q or running Lua scripts with Redis will still be able to run all those components, and that was a deliberate design choice. Now, if you're talking about the implementation of Dragonfly, so for me it started as a challenge basically to myself. I didn't start from thinking about opening a startup. Basically, I left Elasticache team and stayed at home during COVID. It wasn't a very nice period of my life. Had to code a lot of lines of code at night because my twin daughters were just born, and had to juggle everything. And I was not working, and yeah. But basically, I started with a very simple kind of challenge or milestone. Let's implement a toy backend that can only answer on or only can handle set and get commands, and I called it MIDI Redis. And again, it was more like a learning experience for me of can we really do it? Like I wanted to learn about shared nothing architecture, how to do it. Also, a new Linux API was recently released called IOUring, and I was excited about it. It was just released, and I took everything as a learning experience opportunity, and I spent more or less 2 or 3 weeks just coding, and so it works. Like I could create or wrote a very simple backend, and it's, by the way, it's still available on GitHub. It's called MIDI Redis under my username, and it reached like 4 million TPS on a single machine on AWS, and I was really excited about it. And I thought, okay, I have something. And then I collaborated with my co-founder Oded, and we decided to push it forward. And my next milestone basically was around innovation of hash tables. What kind of hash table can I use for Dragonfly? And how can I improve the things, like major things that bothered me when I was using Redis? And it was again single threaded nature of Redis, and its lack of resilience when doing snapshotting. Basically, I really hated its snapshotting algorithm that was based on fork system call. I felt that it's very unreliable. So it was my next challenge, and I solved that challenge, and then I continued with blocking comments. And around April, so I started like November 2021, and around April, I felt okay. We have something. We have something workable, and I succeeded to implement my first like blocking command. I thought, okay, maybe we have something interesting here. What could be interesting to other members of Redis community. So that's kind of a short version of how I started. And sorry, yeah, I had to re-implement most of the building blocks myself. Maybe I could use C star for that for some of the work, but I just felt that I need this hands-on experience to really understand what I'm doing. And I not saying that it's the right way to build stuff. For sure, it's not the fastest one, but that's something that worked for me.
In terms of the overall objective of Dragonfly, you mentioned running into limitations working with Redis as far as vertical scalability. You've mentioned some of the limitations in terms of performance, the throughput capabilities that you've unlocked with your early experimentation and what you've now built with Dragonfly. I'm curious if you can talk to what were your overall objectives in building this system and some of the ways that the design and implementation, as well as the overarching goals of the project, have changed from your first phases of experimentation to where you are now, where you're actually building a business around this core technology.
Great question. I don't think I have the full answer even today. So basically, when I started, I think also Dunning-Kruger effect kicked in. So I thought I have a solution, right? I did this experiment, came up with a very efficient data store that could answer set, get, and maybe other commands very fast. And I thought, okay, I cracked this piece of data structure, this piece of infrastructure. But then I discovered how complicated the whole ecosystem is and how much effort is to support Lua scripting properly, how much effort is to support pipelining properly. All those things that I haven't thought about, haven't think about. And my kind of first naive thought was just by improving the performance of those basic operations, I'll be able to win other developers right away. And then I saw that, again, all those fragmented use cases that cover the entire ecosystem of Redis with all those frameworks. And we just had to kind of optimize memory usage, efficiency for all those use cases. And yeah, the strategic goal was cost efficiency. That kind of the umbrella, the high level umbrella of what we try to achieve is a cost efficiency. After that, if we add a new command or new API to, let's say, Dragonfly, it won't move a needle. And there is a natural inertia in the market, right? Because of the frameworks, they need to pick up this command in order to use it, but they are right now largely dependent on Redis. So I felt that just by disrupting the cost factor of the current use cases, we'll be able to win over the market. And we're still working on it, right? So we started with multi-threading, then we continued with memory efficiency. We re-implemented sorted sets. We greatly improved snapshotting algorithm, and we started seeing how people started switching over to Dragonfly because of these advantages. But there is long road ahead of us. So basically, really huge use cases, say enterprise scale use cases, require more sophisticated features like cross-region replication, maybe like better auto-scaling support. So basically, now we are going into this control plane territory where we have maybe the basic block of this very efficient backend, and now we need to build upon it those sophisticated use cases to support enterprise customers. And that's what we do nowadays.
As you have seen teams migrating from Redis or Valkey onto Dragonfly, obviously there are the cost and efficiency gains, and you mentioned the scalability benefits. But beyond those, I guess, financial motivations, what are some of the ways that you've seen it change the ways that teams think about how and where to apply that Redis and key value and queue based functionality in their overall architecture, or the ways that they're thinking about the role of that memory, efficient memory storage in their overall system design?
Yeah. So actually, our first early adopters were not necessarily people that try to save on costs. These were teams that were self-hosting Redis clusters with let's say up to dozens of shards, and it was an operational nightmare for them, and they switched to single node Dragonfly. So for them it was the operational pain that has been solved, and they not necessarily became our customers. So that was mostly community users. Yeah, and this one case, another case. So we saw, and again, it's around the operational complexity, I guess. We saw people optimizing, let's say, dividing their infrastructure, their clusters into separate entities just because of the different throughput needs. So for some high throughput use cases, they needed read replicas, for example, and for others, they could use a single master cluster, and it was totally artificial division just because their original cluster couldn't cope with their load, so they had like to separate and optimize this. And again, with Dragonfly, with its vertical scale, they could just unify everything, and not only it simplified their infrastructure, like it reduced the complexity of their infrastructure, but also reduce the hardware footprint, because now they could average their workload, and the traffic actually became less volatile just because they unified their infrastructure pieces together. It's a similar use case, I guess. And another, I would say, anecdotal example is that we had a customer actually that is very excited about Dragonfly. One thing that they told us is that they accidentally stumbled upon an API that is Dragonfly specific called CL Throttle, that originally came from a module that someone implemented for Redis, and we just implemented as a core Dragonfly functionality. And before that, they used a Golang library for that. And it was kind of complicated and very inefficient. And now they had this built-in API call that simple that they could use, and they're very happy about it because it scales very well with Dragonfly. So basically, there is no, one single answer to your question, but we hear all the time about different advantages of using Dragonfly. Just sorry, maybe it's too long, but I'm super excited about every time when I hear about people using Dragonfly different ways. It's just another morale boost. So few months ago, we heard about Mastodon folks adopting Dragonfly, and it started with them opening a bug in Dragonfly repo. So it wasn't a smooth sale for them, but basically once we fixed this bug, we were super happy about Dragonfly because again, it allowed them to reduce their hardware footprint because of Dragonfly being super efficient in memory. So instead of, if I remember, instead of using 20 gigabytes of RAM, they could store the same workload with 6 or 7 gigabytes with Dragonfly. Those are kind of the use cases. I guess the last one still falls under the cost efficiency umbrella. And I would say the scaling factor is, I would say, around 30% of the use cases when people can't scale the workload with Redis cluster. So it's not even about cost efficiency, it's about them scaling horizontally and still seeing their shards overheating. And that's, I would say, at least based on my experience, it's not the majority of use cases. Majority is still cost efficiency, but still kind of significant amount of use cases that come because of that as well.
Another interesting aspect of what you're doing is that it is a very memory intensive system. It's very focused on speed and efficiency, but with memory being the key resource that's required, obviously correctness around memory usage is very important. And I'm wondering what your thoughts are on, if you were to restart it today, would you still go with C++, or do you think that it would be useful to at least use Rust for portions of that? I'm just wondering what your analysis of that in terms of language choice has been as you've continued to build and evolve the system.
We had a huge amount of bugs around memory semantics and multi-threading. We had huge amounts of bugs around other areas that with any language wouldn't have there as well. But I would answer your question like this. If I would start today, I probably would still use C++ just because it's the tool that I know best. If I would start 20 years ago, being 20 years younger, and Rust would be exist back then, I would probably start with Rust. Yes, I just didn't want to waste my time on learning. And it's not just about the new language, it's about the entire ecosystem of libraries that I didn't want to spend time, learning. But I totally get the advantages of using Rust. I'm not against Rust. I actually used it in AWS. I learned it there a bit, and I enjoyed my short time with Rust back then.
And in your work of embarking on this experimental project leading to building a new database engine and building a business around it, what are some of the most interesting or unexpected or challenging lessons that you learned on that journey?
Just about our assumptions of how people use in-memory stores. It's basically 50 shades of gray. And I kind of knew about it when I was working in the Elasticache team. But then when we launched the project in the community, I actually started only then to start to understand the complexity of the ecosystem, about our assumptions, who would be our first kind of early adopters. Like our hope was that it would be cloud users, but it was the opposite. And then, like with cloud users, I think Dragonfly is best for large scale workloads. But first, we went through the whole journey of onboarding small users, building the data store suitable for them, optimizing even for smallest use cases, and then slowly going towards bigger and bigger customers. It was kind of maybe naive expectation on our side that it's going to be reversed just because the market is already there. That was our kind of thought, that just because we are building drop-in replacement and it's fully compatible, it will be easier to onboard bigger customers. And it didn't happen easily. But besides that, I don't know, just a random request from commercial users that were unrelated to maybe to the data plane requirements and to the technology of data of Dragonfly itself. All the mechanics of the cloud system, of the automated service, all those features that we need to implement before commercial users start working with us. That was also kind of unexpected. Luckily, um, we have the best team, cloud team, engineering team, and we could solve all those challenges very quickly.
To the point of Redis compatibility, obviously that gave you a very focused target to aim for in terms of the implementation. It helped with the adoption curve as far as people not having to re-implement any of their tech stack, their libraries. They could use the existing set of technology that they were using. They just swap out one component of it. Now that you have that in place, I'm curious what your thoughts are as far as extensions to that interface that would be useful, or additional features beyond the bounds of Redis that are in consideration for adding to or extending the capabilities and use cases of Dragonfly.
I could actually ask the same question back to you. Let's say you would develop a new SQL database. Do you think that there is an API command that would be disruptive in this market, or something that, let's say, would quickly move MariaDB or MySQL users to your database if you would create it? So I don't know what you think about it, but my thinking is that there is no such magical command that would do any like quick wins in terms of adoption just because we have it and our other technologies do not have it, and we are still on our path to disrupt, I would say, that the core attributes of in-memory data store. And what I mean by that is that our next goal is to make Dragonfly a fusion store, basically something that can use SSD, local SSD, very fast NVMe drives, and to provide the same look and feel as in memory store, but reduce this dependence on memory. Like you mentioned memory before, that it's very important component. Usually it's also the biggest cost contributor when people use in-memory stores. And that's something that also prevents them to move huge workloads to in-memory space. They would love to benefit from low latency, high throughput, but they can't due to high memory costs. And memory costs are not going down as fast, at least, as SSD cost. So our, I wouldn't say near term, but maybe mid-term goal milestone is to introduce SSD tiering that would be able to benefit from SSDs and offload huge chunks of data from Dragonfly, and by that to reduce total cost of ownership by a factor of 10, let's say 5. It will still be a huge win.
For people who are using Redis or evaluating use cases that are adjacent to Redis and that ecosystem, what are the cases where Dragonfly DB is the wrong choice?
I think when people, not Dragonfly, but in memory store in general, some companies marketed Redis, for example, as a database. As an engineer, it makes me hurt inside. Redis is not a database, Dragonfly is not a database, and some maybe naive folks think that Redis can be used, or in memory store can be used as a database. I think everything that involves durability and strong consistency guarantees of transactional guarantees of all operations, for those use cases you can't use in-memory store. There is inherent trade-off there, that in order for in-memory store to be fast, it never records its actions, so it can't roll back transactions in case they fail. And I think it's a great trade-off for use cases that do not require transactional guarantees. And there is a huge market for those use cases. But people should be aware of these trade-offs. What else? Besides that, I think anything that requires high throughput and sub-millisecond latency must use in-memory data store. And it's kind of an unfortunate outcome. Like people think, okay, local SSD, for example, let's build something that uses SSD. The thing with SSD is that it has a low latency. Actually, it's really great in terms of latency, but it is limited in terms of IOPS that you can perform compared to memory, like several orders of magnitude lower operations per second that you can do. And I don't think it's going to be solved in the near future unless something like persistent memory will appear again. Like Intel tried this, it didn't work out, but without it, high throughput use cases won't run anywhere else in a cost efficient manner. That kind of my general advice. Like use in-memory data store for super high throughput use cases, and do not use it if you require transactional semantics and good durability guarantees.
Are there any other aspects of the work that you're doing on Dragonfly, the overall ecosystem around Redis, the use cases for memory stores that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, sure. We also follow the general trend of of the AI revolution, and we added support for vector search. It's still very much naive, I would say, but it exists. And for people who already use in-memory data store and they need attribute search together with vector search in a single query, which is extremely useful, we can provide a very good alternative to other solutions. So basically, there is this debate of either vector search database that are narrow, focused on solving this problem will survive in the long term. And the general opinion is that they don't have enough reasons to run a dedicated database only for vector search. And as I said, in-memory data stores are very flexible with their use cases, and usually people already run them for other needs. So here is the chance of using something like Dragonfly for classical use cases and also for vector search and document search like JSON and et cetera, et cetera.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Interesting question. Actually, I wouldn't lie. I do not have enough insight for to answer this, just because I am on the other side of the mirror. Basically, I learn about data store, database needs from my users, from my customers. Surprisingly, I do not use lots of databases myself, ironically, maybe. So I can't answer your question, unfortunately.
Fair enough. All right. Well, for anybody who wants to try out Dragonfly, I'll add links in the show notes. I appreciate you taking the time today to join me and share the work that you've done, your journey to building this system, and all of the effort that you're putting into improving the scalability and cost efficiency of these memory store use cases. So thank you again for that. And I hope you enjoy the rest of your day.
Thank you, Tobias, and have a great day.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.